In the previous class, we were discussing about the chemical reaction. We defined what chemical reaction is and what are the indications for a chemical reaction, like change of color and difference in temperature. So likewise, we have explained all the chemical reactions, and we also discussed about the representation of a chemical reaction by element symbols, and we know how to balance the chemical equation along with the physical states of the reactants as well as the products with the reaction conditions. Now in today's session I'll be explaining about the different types of chemical reaction. So first of all, for a chemical reaction to occur, there should be a breakage or cleavage of chemical bond. So the chemical bond is cleaved. You have got the reactant, you have got the product. So in the reactant, it has got certain chemical bond and that is broken so that a new entities are formed as products and byproducts. Now we are going to discuss about the different types of chemical reactions. Okay, right. Take down. See the different types of chemical reactions. One is combination reaction or combination reaction type 1. Second type, decomposition reaction. Please take down. Combination reaction, write down combination reaction, then decomposition reaction. Okay, decomposition reaction. And the third one is displacement reaction. Displacement reaction. And we have double displacement reaction. Double displacement reaction. Then we have oxidation and reduction. So what are the types of chemical reactions? Combination reaction. Have you noted down? Combination reaction, decomposition reaction, and then you have displacement reaction, oxidation and double displacement reaction followed by redox reaction, and which is nothing but oxidation and reduction. Okay, right. Now let us discuss the first one. Types of chemical reactions. Combination reaction. Combination reaction means, that is, let us see by an example. You have got a quicklime that is also called calcium oxide. So what is calcium oxide? How to write down the calcium oxide? You know, we have this calcium oxide. Always remember how to write the molecular formula from the name. Calcium oxide. So it has got calcium 2 plus ion, O2 minus ion. Okay. So we can combine straight away, and this is the AB type, is it not? That is 1:1 combination. So CaO, both of them are 2:2. So they are cancelled. The charges are cancelled. So CaO. This is nothing but calcium oxide. So we have taken this calcium oxide, that is also called quicklime. And within bracket it is indicated as S. What do you mean by that? That is nothing but solid. Okay, so this is solid. So let me write this calcium oxide. Calcium oxide, which is a solid. Okay, right. Then we add water to this, H2O. It is in the liquid form. It gives slaked lime. Okay, slaked lime, that is nothing but calcium hydroxide, CaOH twice, calcium hydroxide, and with that heat is also evolved, and that is why it's called exothermic reaction. Exo means out, thermic, heat. So heat is given out during this reaction. Okay. So calcium oxide and water, they combine. So when you take this calcium oxide and mix it with water, what happens when you pour water in calcium oxide? It will be boiling like anything. Even though we are not heated, there will be lot of bubbles. So it means that is, it gives out the heat. So it will be very hot also. Okay, like a boiling liquid, that is, the heat is generated here, right? And in this case, a single product is formed. Remember, this is reactant 1 and another reactant, it can also be called a reagent. So two reactants combine to form a single product, and that's why it's called combination reaction. Do you understand this? So what do you mean by combination reaction? What is the condition for that? You have to get one product from two reactants. Okay, so you can note down here a reaction in which a single product is formed from two or more reactants. They can be called, such type of reactions can be called what? Combination reaction. Do you understand this? Right. So let us discuss some more examples also. Okay. So we have, let me explain the combination reaction with additional examples like burning of coal. So burning of coal means that is, you got the carbon, then it is in the solid form. It is burnt in presence of oxygen, that is in the gaseous form, so that a single product is obtained, that is nothing but carbon dioxide, that is gas. Got it? So what type of chemical reaction it is? Combination reaction. Why? Reactant 1 combines with the reactant 2 to give a single product. Got it? And let us have another example, that is formation of, take down, formation of water from hydrogen gas and oxygen gas. So let us combine these two gases, hydrogen in the gaseous form, oxygen in the gaseous form. So it gives H2O, which is in the liquid form. So this is reactant 1, this is reactant 2, so that you are able to get a single product, that is water, but it needs to be balanced. So here you have O2 and here there is only one O, so you can put 2. So 2H2, so you can put 2H2. Now it is balanced. Okay? Right? And we have some exothermic reactions also. For example, exothermic reactions. Burning of methane. Take down. Burning of methane. This is called methane, also natural gas. Natural gas. So burning of natural gas. You can write down burning of natural gas. That combines with 2 moles of oxygen gas to give carbon dioxide gas and H2O liquid. Usually most of the organic compounds, they undergo combustion. Combustion means burning in presence of oxygen, okay, to give carbon dioxide and water. Okay. Even during digestion, food is broken into simpler substances, is it not? Food is broken into simpler substances. For example, we take a rice, potato, sambar, etc. Okay, in various forms, and also bread. Usually, these rice, potato, bread, they contain carbohydrates. So the carbohydrates are broken down to form glucose. And this glucose combines with oxygen in our cell of our body in order to provide energy. Okay, and in fact, that is during respiration, that is you will be imbibing, that is absorbing or inhaling what gas? Oxygen. Okay, right. So we obtained the food from what do you call this, glucose. Take down C6H12O6. So this is glucose. Okay. This is in the aqueous form. Aqueous form means solution form. Now the oxygen 6O2, that is also available in a liquid form. After inhaling, it is mixed with the blood, is it not? So we have got the oxygenated blood. Okay. So using this oxygen in the liquid form, that is you can put aqueous form, right, to give 6CO2, and the 6CO2, this is also available in the aqueous form only. Then water molecule, 6 moles of water, and that is in the liquid form. With that, the energy is also released. That energy is stored and used up by our body cells. Do you understand? And this is the process of respiration. We call it respiration. Okay. You may wonder how we got this oxygen in the aqueous form. Actually, we breathe this as what? Gaseous form. But after it is converted into an aqueous form to get the aqueous form from the gaseous form. And that aqueous oxygen is used up to to break glucose further to give carbon dioxide, that is also in the aqueous form, and that is again converted and formed as a carbon dioxide gas, and we are exhaling as gas. So when we inhale, we take oxygen in the gaseous form, and that is converted into an aqueous form in the blood. Okay. And what about this oxygen? That dissolved oxygen in the blood, carbon dioxide in the blood, is exhaled as a gaseous form, and we give the byproduct water, and we urinate or respirate or perspirate, and then there is an evolution of what? Energy. There is a formation of energy. So this energy is used up by the cells, and it is also stored in our cells for futuristic activity. Okay. So this is the case with what? The respiration. So you can call it as a chemical reaction behind the respiration. Okay. So how we got this? This is the part of respiration. How we got this glucose? By digestion. Where from? From the carbohydrate. What about that carbohydrate? They are all starches, cellulose, not cellulose, mainly starch. Okay. And we have got maltose, etc. So all these carbohydrates are broken into simple molecules like glucose, and it is further broken down into carbon dioxide, water, then energy is released. So don't forget this. Okay. Right. Then now we have decomposition of vegetable matter also, is it not? And that vegetable matter is decomposed into composts. Okay. And that is also giving giving out heat as that is also exothermic reaction. Now let us go for the decomposition reaction. Take down. Decomposition. Type 2. Decomposition reaction. So in the case of decomposition reaction, a single product is what? Not single product, single reactant. So single reactant is broken down into simpler compounds. Take down ferrous sulfate, FeSO4. That is in the solid form. When it is heated, this triangle symbol indicates heat. So when it is heated, you are able to get ferric oxide, Fe2O3. Ferric oxide, and that is also in the solid form. Then you have sulfur dioxide gas. Along with that, you are able to get sulfur trioxide gas also. Now, this is a single reactant where from you are able to get what? Product 1, product 2, product 3. Okay, so if you are able to get different products from a single reactant, then it's known as decomposition reaction. I can cite another example, calcite, calcium carbonate. What is this? Calcium carbonate is a solid. When it is heated, you are able to get quicklime, that is calcium oxide as a solid and carbon dioxide as gas. Okay, so this is known as limestone. And what about this? This is quicklime. Quicklime, okay, which is nothing but calcium oxide. You should know the ionic formula also, Ca2 plus CO3 2 minus. So they combine to form what? Calcium carbonate. Okay, and similarly here calcium 2 plus, oxygen 2 minus. They combine to form calcium oxide. Okay. Now let us have another example, lead nitrate. Okay. PbNO3 twice. Why I put twice? Because for lead it is plus 2. Okay. So for lead it is plus 2 oxidation state. And what about this NO3? This is single minus. So you have to adopt that crisscross technique. Okay. So it becomes PbNO3 twice, right? When it is heated, is it in the solid form? When it is heated, you are able to get PbO, that is lead oxide. Lead oxide. 2 moles of PbO, and here you have got 2 moles of PbNO3 twice, plus 4 moles of nitrogen dioxide, NO2 gas, and then oxygen as gas, right? And what about this type of reaction? This is also decomposition reaction. Why? A single reactant, by heating it, you are able to get different types of reactants. Okay. Similarly, you have silver chloride, AgCl, that is in the solid form. That undergoes a decomposition in presence of sunlight. This is called photon. Photon means light. So from the sunlight, by keeping this chemical in the sunlight, you are able to get Ag, and the chlorine is liberated as gas. So you are able to get silver. Okay. So this turns gray. The silver chloride is white and that turns gray as silver. Similarly, silver bromide, AgBr, solid, in presence of sunlight. Sunlight can be represented by photon. This is called H and this is nu. Photon. Photon means sunlight particles, and here you have H is called Planck's constant, and nu is, this is called nu, that is called frequency of the light. So together the product of Planck's constant and nu is called photons, and the light consists of this photon. So when the light falls on silver chloride or silver bromide, it is decomposed into silver and the respective halogen. So Ag, S plus, in this case Br2 as gas. Okay. Now let us move to the next type. So what is this? What are these examples? These examples stand for what? Decomposition reaction. So what is the difference between decomposition reaction and a combination reaction? In combination reaction, there are two reactants and one product. Okay? But in decomposition, there is a one reactant, two or three products or many products. Okay? Usually heating takes place during the decomposition. Yeah, more than two products are formed from a single reactant. Now let us move to the next type, that is displacement. Take down. Displacement. Displacement reaction. Now in this reaction, one element, one atom is replaced by the another element. Okay. For example, silver, not silver, iron, Fe, it is in the solid form. Now copper sulfate, CuSO4, it is in the aqueous form, that is in the solution form. Copper sulfate. Now what happens? This copper is replaced by iron. So you are able to get FeSO4 plus copper is displaced as solid, and this is in the solution form. So what do you call this one? Copper sulfate. What about this? Iron sulfate or ferrous sulfate or iron 2 sulfate. What are the ions involved here? Copper, what is that? 2 plus, SO4, 2 minus. And that's why you are able to get copper sulfate. In this case, Fe 2 plus, right? And SO4 2 minus. They combine to form iron 2 sulfate. Okay? You can either call it ferrous sulfate or iron with the Roman letter 2, that indicates the oxidation state of iron. Iron 2 sulfate. Okay, right? So which replaces the copper? Iron replaces the copper, displaces the copper. So that is why it's called displacement reaction. Similarly, we can have zinc. This is in the solid form. That reacts with the copper sulfate in the aqueous form to give, can you guess? Zn SO4, that's all. Okay, zinc plus what is removed here? Once again, copper as solid. This is also what? Displacement reaction. And what is this? Lead plus. You can introduce copper chloride, CuCl2, aqueous solution to give, can you guess what could be the product? Pb displaces copper, so PbCl2 and copper is displaced. Are you able to follow? So PbCl2 in the aqueous form, what do you call this? Lead 2 chloride or lead chloride. Okay, lead chloride. Now let us discuss about the double displacement reaction. Double displacement reaction. In the case of double displacement reaction, two elements are replaced here. For example, Na2SO4, what do you call it? Sodium sulfate in the aqueous form, plus barium chloride, BaCl2, that is also in the aqueous form, solution form. Now what happens? In place of sodium, barium replaces, so barium sulfate. Okay, and what about this? This becomes sodium chloride. Are able to follow? 2 moles of sodium chloride. Okay, so in this case double displacement takes place, is it not? Okay, so since they produce a precipitate, this can also be called precipitation reaction. Usually the precipitate can be represented, this is precipitate and this is in the aqueous form, because that is soluble in water and this is not soluble in water. That is why it is available as precipitate. So when I indicate an arrow mark downward, that is precipitate. Okay, upward arrow indicates gas. And the fifth one, redox reactions. Redox reactions means oxidation as well as reduction takes place. First of all, you should know what is oxidation and what is reduction. Oxidation is nothing but addition of oxygen. Reduction is removal of oxygen. You can also explain oxidation in terms of hydrogen. So removal of hydrogen is oxidation, addition of hydrogen is reduction. And we can also define oxidation in terms of electron. So de-electronation, that is the loss of electron. Loss of electron, removal of electron is oxidation. Gain of electron is reduction. You can simply remember this by Leo, loss of electron is oxidation. Leo means tiger, lion. You know tiger, is it not? And this is Leo Gar. Gar means GER, gain of electrons. You just remember this oxidation and reduction as Leo Gar as a mnemonic. Leo means what? Loss of electron. Gar means gain of electron. The lion will be roaring and the sound will be grrr, is it not? So Leo Gar. Then increase of oxidation number is oxidation. Decrease of oxidation number is reduction. And oxidation is the reaction that takes place at anode. Therefore, it can be called anodic reaction. And this is cathodic reaction. Which one? Reduction. So likewise, we have 5 types of definitions for oxidation and reduction. So you have to remember this, right? Now let us have copper plus oxygen gives copper oxide when it is heated. Okay, so you are able to get 2 moles of copper and 1 mole of oxygen, so that you are able to get 2 moles of copper oxide. Now we must justify whether it is a reduction or oxidation. In fact, both of them will take place simultaneously. That's why they are called redox reactions. You just check it up here. Now, what is the oxidation state of copper in its natural state? 0. What is the oxidation state or oxidation number of oxygen in its natural state, that is in molecular form? 0. And what about the oxidation number of copper in copper oxide? Plus 2. What about oxygen? Minus 2. Got it? Now the copper becomes copper 2 plus. Am I right? Okay. So copper becomes copper 2 plus. Cu becomes Cu 2 plus. Whether it has lost electron or gained electron? It has lost electron. 2 electrons. Okay. So that is why it undergoes oxidation. So you can mention this as oxidation. So copper has undergone oxidation here by loss of 2 electrons. Do you understand this? Because you have got plus 2 and E represents minus. So 2E, 2 minus, 2 plus cancels 0. So you are able to get 0 here. Okay. And similarly, oxygen O0 with oxidation state, that becomes minus 2. Whether it is a loss of electron or gain of electron for oxygen. Very good. So it is a reduction, that is represented as H. So you have O2, that becomes what? O2 minus. Do you understand this? So by adding 2 electrons, okay? By adding 2 electrons, okay? Is that clear? So now we have, that is 2 electrons, so 2 minus. This is addition of electrons, so it should be represented as H. So since they involve both, they are called redox reactions also. They are called redox reactions. Do you understand? Okay. So you must be able to identify the reaction, whether it is redox reaction or not. Shall we try one more reaction? Zinc oxide, take down. Zinc oxide reacts with copper, carbon. Zinc oxide reacts with the carbon to give zinc and carbon monoxide. CO2 is carbon dioxide, CO is carbon monoxide. Okay. Now let us identify what is the oxidation state of zinc in zinc oxide, that you can work out. You know already oxygen is minus 2. This carbon, it is natural state 0, and this is also 0, and this is minus 2. So you have to check zinc and this carbon. So let us consider, put zinc, X for zinc in zinc oxide. This is minus 2. So you can put X minus 2, is it not? Actually that is X plus of minus 2 is equal to 0. X minus 2 is equal to 0. X is equal to plus 2. So the oxidation state of zinc is plus 2. Okay. Similarly, you had to find out here. CO, is it not? So for this it is minus 2. And what about this carbon? It should be plus, is it not? Plus 2. Okay. So put X for this. So X minus 2 is equal to 0. X is equal to plus 2. So you can put this is as plus. Got this? Now zinc becomes what? Zinc 0. It means Zn plus 2 becomes Zn. Means 2 electrons are added. Whether it is reduction or oxidation? Reduction, because addition of electron. Okay. And what about this carbon? Carbon undergoes, that is a C plus 2. In this case it is 2 electrons are released here. Are able to follow? So C becomes a C plus 2. Got this point? So we can prove that, and you have to label it. This is oxidation. So what about this? This is reduction. and this one is oxidation. Okay, that is why it's a redox reactions. Got it? Shall we try another reaction? Take down manganese oxide MnO2 plus 4HCl to give manganese chloride MnCl2 plus 2H2O plus Cl2. Okay, now let us try. What about this manganese? This is -2 and this one, yeah, you can check, put X for this, so X plus, there are 2 atoms of oxygen with the -2, net is 0, X plus X minus 4 is equal to 0, so X is equal to plus, you can mention this as +4. Okay, and what about HCl? So H is plus, Cl is minus, so -1 for Cl. So in this case MnCl2 means this is +2. And what about this? Chlorine is 0. Now let us identify. +4 becomes +2 and -1 becomes a 0. Are you able to follow? So +4 becomes a +2 means a decrease in oxidation number. So what is decrease in oxidation number? Reduction. And what about this? -1 becomes a 0 is increase in oxidation number. Is it not? Okay, so it can be oxidation. So you can rewrite here manganese +4 becomes manganese +2. Got it? By what? By adding 2 electrons. So it should be reduction. Got it? And what about HCl? That is Cl minus becomes Cl20. So in that case it becomes what? 1 electron is removed here. If there are 2 atoms of chlorine, 2 electrons are removed. That's all. I am taking only the cation, anions. Do you understand this? Now let us proceed with the next concept, that is a very important concept called rusting, that is corrosion. Corrosion and rancidity. Corrosion, let me consider a metal, and because of the oxygen and water, what happens? Rust is formed. Okay, so this is iron oxide, that is an oxide layer is formed, and this is the metal. So metal in combination with oxygen in presence of water to give metal oxide. So this kind of, that is a formation of, take down, formation of oxide layer over a virgin metal, over a metal is called, what is that? Rusting. In case of iron, it gives red rust. In case of copper, it gives green rust. In case of aluminum, it gives, what is that? White rust. Okay, so likewise, based on the nature of the metal, the rust colors may differ, but all are formed as, what is that? Metal oxide. So how can you protect these metals from corrosion? There are 2 agents which are responsible for oxidation here or rust formation. One is water, another is oxygen. So either you have to remove oxygen, you have to remove oxygen as well as water. So when the metal is free from oxygen and water, it won't get rusted. Okay, and that is why in electronic goods, when it is supplied through courier, okay, you could have found some gels, and it is a dehydrant, actually dehydrating agent. It removes water and moisture. What is moisture? The water content present in the atmosphere is called moisture. So we can avoid by applying oil. Okay, we can avoid rusting. Are you able to follow? Now, our natural property is getting lost because of this rusting, since these metal components like bridges, automotives, they are exposed to natural atmosphere, natural climatic conditions. It contains what? Oxygen as well as water, is it not? So because of this, we are losing enormous metals. Okay, so that should be protected. So prevention is better than cure. And how can we prevent corrosion? We can prevent corrosion by applying oil, or by applying paint, or by galvanizing also, applying 1 quart of zinc. Okay, that is called sacrificial protection. This zinc doesn't allow the iron to get oxidized. Okay, and it sacrifices by itself, and thereby it protects the metal or iron, and that's why it's called sacrificial protection. And it's called the process of applying a zinc layer over the iron. Usually we apply this kind of coating, that is a galvanized coating. It's called galvanized coating. Okay, so this can be done by cold or a hot dip also, or electrochemically it can be coated. So this galvanized iron is called GI, and that is why we have GI pipe. What do you mean by GI pipe? That is used for passing water from one place to another place. After all, these are all the GI pipes. So nowadays they are replaced by PVC pipes, that is plastic. But always plastic is a killer. Okay, so better we can use the metals, but it should be duly protected from corrosion. Okay. Now let us move to the next topic called rancidity. What is the rancidity? Usually the food contains fat and oil, is it not? Rancidity. The food contains, normally that is, it may contain fat or oil. Okay, and when it is left for a longer time, what happens? They are oxidized. Okay, this fat and oil are oxidized, and thereby you are able to get a mal odor, that is a foul smell. Okay, foul smell, and there will be a change of taste also, is it not? Change of taste. So this is because of the oxidation of fat and oil present in food, and that phenomenon is called rancidity. So what is the rancidity? Rancidity is nothing but the change of taste and mal odor or foul smell from the food containing fat and oil. This is due to what? This is because of oxidation of fat and oil. So in order to prevent that, we use antioxidant. Okay. So this antioxidant is used to prevent such type of what? Rancidity. And also it is given in airtight container, so that you can prevent oxygen. Airtight container. Sometimes we can have vacuum packing. So these are all the various methods we can use. Sometimes that is we allow the inert gases also if it is not harmful. So likewise, generally vacuum packing is done nowadays. You could have seen some that is a ready mixed food duly packed with vacuum. So they suck out the air present inside the packing. Okay, and you can have a lot of wrinkling of these bags because of what? Evacuation. Evacuation means removing water. I mean not only water, that is air. Because this air contains oxygen and water, definitely it will affect the oil and the water. Yes. And sometimes we use chemically we can prevent by introducing antioxidant. Okay, so shall we have some quiz? Right, get ready. What are the different types of chemical reactions? Combination, decomposition, displacement, double displacement, redox reactions, and corrosion, and that is a different concept. So the types of reaction, how many types of chemical reactions? Combination, decomposition to displacement, double displacement, redox reaction. Totally 5 types. Okay, don't forget that. Now, there is a reaction. The reactant gives 3 products. What is the type of reaction? Decomposition. A reactant A combines with reactant B to give a product C. What is that? Combination reaction. Let us have sodium hydroxide that reacts. Please make a note. Sodium hydroxide, NaOH. Write down in your notebook. Sodium hydroxide, NaOH, plus, that is plus represents reacts. Sodium hydroxide reacts with hydrochloric acid to give sodium chloride and water. What is that reaction? It's a double displacement reaction, and it can also be called neutralization reaction. Take that. So neutralization reaction is a double displacement because the acid reacts with base to give salt and water. Okay. So here H as well as Na, both of them are replaced or interchanged. Okay. And then magnesium combines with oxygen to form magnesium oxide. What type of reaction it is?
Oxidation.
Magnesium combines with oxygen to give magnesium oxide.
Displacement.
How displacement?
Composition.
Anyone? Combination reaction, that's all. One product is formed, is it not? Magnesium burns in air, that is oxygen, to give magnesium oxide, MgO. So Mg plus O2 gives MgO, that's all. Single product is formed. So it's a combination reaction, is it not? But this can also be called redox reaction. Why? Let us explain. Mg reacts with oxygen, is it not? So this can also be called redox reaction. Why? Because there is a change in oxidation number. So whenever a reaction is accompanied by the change in oxidation number of the elements present, then it can be called redox reaction. For example, Mg plus O2 gives MgO, right? So 2MgO, 2Mg. Now, what is oxidation state of magnesium? 0. Here 0. What about this? Plus 2. What about this? Minus 2. Now let us indicate magnesium 0 becomes plus 2. So 0 becomes plus 2 means loss of electron. What is that? Oxidation. Got it? And what about the oxygen? 0 becomes minus 2. It has, yeah, so gained 2 electrons. So it can be called redox reaction. That is reduction. Okay, so Mg becomes Mg2 plus and O becomes O minus 2. So in this case 2 electrons are lost. In this case 2 electrons are gained for each atom of oxygen. Got this point? So in the next class I will teach you how to balance the redox reactions using oxidation number technique. Okay? So you please go through these reactions given in your book. For example, that is exercise given in page number 15, where you have balance the following equation and translate the following statements, that is 4, 5 and 6, and you have to write down this set of reactions. You have to practice all these things, and also this one. So these are very important. So 1, 2, 3, 4, you can take these as worksheets. Okay.